So I want to take you through this differential equation problem for two reasons. Number one, because if you were in my first hour class, we completely butchered the problem when it was asked, and I apologize for that, and I wanted to right my wrong. But number two, there's a little surprise that happens at the end of this problem that we have not discussed in class, and it may very easily come up on the AP exam. It's a small thing, but it's actually kind of cool at the end how this all works. So let's go ahead and get started. So, as we know, the first step to solving a differential equation is to separate the variables. So I'm going to divide both sides by y cubed, or I can say multiply both sides by 1 over y cubed. So that gives me this. And that alone, that's the first step, separate the variables. You have to show that step. You've got to earn that first point by showing that step. If you don't separate the variables, you lose 4 points on this problem automatically. Now we're going to go ahead and integrate 1 over y cubed. Sorry, writing sloppy. 1 over y cubed dy dx, but we're integrating with respect to x on both sides. So that's 1 over 3x minus 2 dx. The reason we integrate with respect to x is so that those cancel out. And now I can go ahead and integrate. Now, sometimes in the delta math problem, sometimes when you integrate here, it becomes a u sub problem. This is not a u substitution problem, which is fine. And if you need an example of a u sub problem, let me know and we can meet up, or I can record a video for you. But we're going to go ahead and integrate this thing. So I'm going to rewrite this as the integral of y to the negative 3 dy. And I'm going to go ahead and write this integral over here as 3x minus 2 to the negative 1 dx. I guess it is a u sub problem. We can show the u sub. You might be able to do the right-hand side on your own without a u substitution, but I'll show you how to do it with a u sub, just so you know. All right, so on the left-hand side, I'm going to add 1 to the negative 3, and so that's negative 2, and then I'm going to multiply by the multiplicative inverse, so I get negative 1/2 y to the negative 2. And now on the right-hand side, I'm going to go ahead and use u sub, so I'm going to show my work kind of off to the side. It's like scratch work. So we're going to let u equal 3x minus 2. We're going to let du dx equal 3. du equals 3 dx. And of course, then dx is going to be 1/3 du. So when I go to rewrite substitute in, I get 3x minus 2 to the negative 1 dx is now going to get written as u to the negative 1. And this dx right here gets replaced with 1/3 du times 1/3 du. Okay, so now when we integrate here, this is kind of interesting. I got u to the negative 1. If I try to use a traditional way to find the antiderivative of u to the negative 1, I'm going to get into problems because negative 1 plus 1 is 0, and I certainly can't multiply by 1 over 0. So here's the key. When you have, I'll put the 1/3 out here. When you have 1 over u, that's the signal that you need a special antiderivative. So your antiderivative of 1 over u is natural log of u, and we'll put the plus c in there. Okay, so now I'm going to go ahead and back substitute. So I get 1/3 natural log the absolute value of 3x minus 2 plus c. And so that's what I put over on the right-hand side of my equation. 1/3 natural log absolute value of 3x minus 2 plus c. So rewriting this and just cleaning it up a bit, I got 1 over 2y squared equals 1/3 natural log of 3x minus 2. Now, plus c. Here's where things went south. I tried to solve this for y right away, but it gets to be a mess. So I think the better move is to use the initial condition. They gave us an initial condition that y of 1 is equal to negative 1. Meaning, if I replace x with 1, the output, the y, is going to be a negative 1. And so I'm going to use that now to figure out c. So I'm going to say 1 over 2 times, I forgot the value, negative 1 squared is equal to 1/3 natural log of 3 times 1 minus 2 plus c. Is it 3 times 1? Yes. Okay, so this gives me negative 1/2 is equal to 1/3 times the natural log of 1 plus c. Okay, so now we're going to solve this for c. So this gives me negative 1/2 equals 1/3 natural log of 3 minus 2, which is 1 plus c. Now, the natural log of 1 is 0. And that should make sense to you. If you are not aware that the natural log of 1 is 0, I want you to think about why that would be. And then, if you need help with that, or you can't figure out why the natural log of 1 is 0, you're going to let me know, and I'll record another video for you. So that gives us c equals negative 1/2. So what I'm going to do is I'm going to plug that c value in back to that part of the equation right there. So what I get is negative 1 over 2y squared equals 1/3 times the natural log of the absolute value of 3x minus 2 minus 1/2. And at this point, we can solve for y squared, or solve for y. And that little hiccup that I told you about earlier, it's on its way. It's almost here. It's not here quite yet, but it will be. So I'm going to multiply both sides by y squared. So this gives me negative 1/2 equals y squared times 1/3 natural log, absolute value 3x minus 2 minus 1/2. And now to solve for y squared, I simply divide. So I get negative 1/2 divided by 1/3 natural log, absolute value of 3x minus 2 minus 1/2 equals y squared. Okay, so here it comes. How do we undo a square? We take the square root. But when I take the square root of both sides of an equation, I need to put in this plus or minus, right? You remember that from Algebra 2. So when I go to write this, here's the issue. This right now is not a function. It's not a function because I have the plus or minus in front of it. And when I have that plus or minus, that means that I'm getting two outputs, a positive and a negative, for every input. So how do I choose? How do I know if it's positive or negative? Well, what we're going to do is we're going to go back. This is the little hiccup that I was telling you about. And it could come up on the AP exam. We're going to go back to the original initial condition. And the initial condition said that when y is equal to 1, the output is negative. Well, there's only one way I can get this output to be negative, and that is to get rid of the positive. So that right there is going to be my solution to the differential equation. Okay, so that's it. Practice a couple more of these on Delta Math. If you need anything else, don't be afraid to shoot me an email. I can record a video for you on any topic that you need.